Hey, it's Coach Latham, your SOL geometry coach, and today we're going to talk about circles, and as always, we're going to try and do it in 15 minutes or less. On this screen, you've got some important stuff that you should have learned in middle school, most notably that the circumference of a circle is equal to 2 pi r and that the area of the circle is equal to pi r squared. How that shows up in geometry is that you'll be given a circle with some measure, either the diameter or the radius, and you'll be asked to find the circumference or the area. Go ahead and hit pause, jot down your answer real quickly on this, and give it to me both ways, one with pi in the answer and one with pi approximated and multiplied out. And here are the answers. It's simply a matter of plugging in 5 and working it out. I prefer the answers 10 pi for the circumference and 25 pi for the area, but you'll often need to work it out by multiplying pi out. Make sure you know where that button is on your calculator to save you the trouble of typing it in. The next thing we're going to talk about are what I like to call pizza problems. They're based on what we just did, whether you know the circumference of a circle or the area of a circle. And then we're going to just find a fractional part of it. Both of these problems are done the same way. The first thing that we're going to do is find the entire circumference of the first circle and the entire area of the second. And we've done that. We find the circumference of the circle on the left is 31.4 or 10 pi, and that the area of the entire circle on the right, since the radius is 12, is going to be 144 pi or 452.4. Our next step is to find out just the section of the circumference or the area that we're working with. In the circle on the left, we're only concerned about 60 degrees of that circle because we have this angle right here, 60 degrees. So we want to know the 60 degrees that go around the outside. So it's 60 out of a total of 360 times 31.4. And when we multiply that out, we're going to get this section of the circumference. Likewise, in the problem on the right, we're only concerned with 120 degrees of the area, so it's going to be 120 out of 360 degrees in a circle times 452.4. And so after we multiply it out, we get that the portion of the circumference in the circle on the left is 5.2, and the portion of the area in the circle on the right is 150.8. The next thing that you need to know about circles are things called central angles and inscribed angles. A central angle is one in which the vertex is at the center of the circle. And what you need to know is if it's an 85-degree angle, then it cuts out 85 degrees of arc length. Since there's 360 degrees going around that inside circle, there's also 360 degrees of arc length going around the outside of the circle. So central angles and arc length match up in terms of degrees. This angle right here, since it starts on the edge of the circle, is an inscribed angle, and its relationship to arc length is that the arc length is always going to be twice as many degrees as the angle of the inscribed angle. You can kind of think of it as the fact that this thing has twice as much time to open up. So by the time it gets to the other side of the circle, it doubles in size. So a 35-degree inscribed angle gets you a 70-degree arc measure or arc degrees, and a 85 degrees central angle gets you 85 degrees on the arc. Here's an example of the type of questions you might see on the SOL test. Go ahead and hit pause, see what you can work out, and then I'll come back with the solution. Okay, to work these out, the first thing we have to do on the problem to the left here, it says find x if the arc ABC is 250, so A goes through B to get to C. So we've got 250 degrees out here in blue. Well, we know that there's 360 degrees in a circle, so when we do 360 minus 250, we get 110 degrees, and 110 degrees is going to be this red arc measure right here. And if we have 110 degrees and we have a central angle that matches to it, then we know that x is also going to be 110 degrees. Over here, you can take a look. What I have outlined in red is an inscribed angle that opens to the other side of the circle. Since it's an inscribed angle, if this is 40 degrees, then we know that this is 80 degrees. Well, working backwards, if we know that this is 80 degrees and we have a central angle that opens to it, then we know that x is equal to 80 degrees. The next thing we're going to look at is what happens when we have two lines that intersect inside of a circle. If we have two lines that intersect inside of the circle and we know the degree measures of the arcs that they cut out, then we can calculate theta, the angle where the two lines intersect inside. It's always going to be the average of x plus y multiplied by half or divided by 2. The easy way to think of it is if you average x and y, it will tell you what theta is. They intersect inside the circle, you average them. The only thing that's different when the two lines intersect outside the circle and impact the circle is that instead of averaging, adding together and dividing by 2, here we're going to subtract the bigger arc minus the little arc and divide by 2. The bigger arc minus the little arc and divide by 2. And then here it's the bigger arc minus the little arc and divide by 2. So if the intersection's inside, add the arcs together and divide by 2. If the intersection's on the outside of the circle, subtract the big arc minus the little arc and divide by 2. So based on that knowledge, go ahead and try these three problems. Please make note that in the bottom problem, you're going to have to subtract 250 from something to find out the measure of the little arc. Go ahead and hit pause and work these three out. All right, here's our three answers. In the first one, we're going to average 100 degrees and 82 degrees. So 82 plus 100 divided by 2 gets you 91 degrees. So theta is equal to 91 degrees. The intersection occurred inside the circle, so you added and divided by 2. In this second problem right here, the intersection occurs outside the circle, so we're going to do the big arc minus the little arc. 80 minus 10 divided by 2 gets us 35 degrees, so this is a 35 degree angle. The third one is a little bit trickier in the fact that we know that the big arc here is identified as 250 degrees. Well, if it's 250 degrees, we'll subtract from 360 and find out that the little arc is 110. So it's 250 minus 110 divided by 2, or 70 degrees. The last thing we need to look at before we go on to equations of circles is what are the lengths of segments as they intersect with circles. And again, we've got a different rule for when the intersection occurs inside the circle. If we have two lines that cross inside a circle, then we know that this distance times this distance is always going to be equal to that distance times that distance, or AB equals CD. It's a little bit harder to get when you're looking at the intersection outside the circle. The way that I try to remember it is that it's the outside part times the whole length. So it's going to be W times W plus X is equal to the outside part times the whole length. So it's going to be Y times Y plus Z. The same thing occurs in this example. The intersection starts outside the circle. So it's going to be Y times Y plus Z. That's right here, Y times Y plus Z. And it turns out with line T for tangent that the outside part and the whole length is the same thing. So it's T times T, which is T squared. With this information, go ahead and hit pause and try and figure out the value of X in the following two problems. Okay, we've got both of these worked out here for you. In the first one, since the two lines intersect inside the circle, we're just going to say that 8 times x is equal to 20 times 6. Here's our equation set up. We're just going to multiply 20 times 6. We get 120. 8x, we're going to have to divide by 8 to get that all by itself. So we end up with the value of x equals 15. The second one's a little bit more complicated, but the intersection occurred outside the circle, so it's the outside part times the whole length, which is going to be 5 times x plus 5, is equal to the outside part times the whole length. They're both 8, so that's 8 squared. Gives you 5x plus 25 is equal to 64 when you distribute. Subtract the 25 from both sides and divide by 5, and we find that x is approximately 7.8. Okay, this next section is probably the most important one that you know for the SOL test. They generally have a couple of questions on the equation of a circle. The equation of a circle is always in this form. And after you've done a couple of them, it kind of makes sense. What you need to know, first of all, is what H and K stand for. H and K are the XY coordinates of the center. They're the XY coordinates of the center. So if we had this picture that we're looking at right here, we can see that the center is at coordinates 3 and 4. So H is 3 and K is 4. So when we go to set up the equation of the circle, it's x minus h, x minus 3 squared plus y minus 4, because 4 is k squared. And then we've got to talk about where this 9 comes from. R is the radius of the circle, so we can just count 1 step, 2 step, 3 steps. We know the circle has a radius of 3 steps. We square 3, and we get 9, and that's how we come up on the equation of the circle. It's x minus the x coordinate of the middle squared plus y minus the y coordinate of the middle squared is equal to the radius squared. Based on that knowledge, let's see if you can determine how to write the equation for this circle. Hit pause and work it out. Okay, so when we go to plug things in here, we find out first that H and K are the coordinates of the middle of the circle, which are negative 3, 1. So we write them down right here. HK is negative 3, 1. So then using this equation up here, it's x minus negative 3. We'll go ahead and simplify that now. X minus negative 3 is x plus 3 squared. Y minus 1 squared, well, that's pretty good the way it is. Y minus 1 squared equals, and then the radius, we can just draw a radius for this circle and count how many units long it is. We take 1, 2, 3, 4 steps. So the radius is 4, and 4 squared is 16. So this is the equation of the circle. Sometimes you're given the equation of the circle and asked to select the graph or to go ahead and graph it. Go ahead and hit pause. See if you can figure out what H and K are given this equation, what R is given this equation, and then go ahead and graph the circle. Hit pause and come back for the answer. Okay, the trickiest part of this problem is figuring out what H is. We've got x plus 3 right here in the brackets, and we know it's supposed to be x minus h. So minus what gets you to plus 3? Well, h is going to be negative 3, because minus negative 3 is the same as plus 3. K is a little bit easier to figure out. It's y minus k, y minus 1, so k is 1. And we have this as r squared. 9 is r squared, so in order to work that backwards, what's the square root of 9? The radius is 3. So if you don't already have this circle graphed, now that you know the center of the circle and the radius of the circle, go ahead and sketch it. I'll hit pause. Okay, so we know the center of the circle is right here at negative 3, 1. We know the radius of the circle is 3, so I'm just going to go ahead and count 3 units over. I'm going to count 1, 2, 3 units up, 3 units left, and 3 units down. And now here's the scary part. Get to test my art skills, see if it's anything close to a circle. All right, I'll make a bigger dot up here. But there is a sketch of that circle. The rest of our time we will spend with this problem. It's a difficult one. It's one similar to those on the SOL test. We're asked to write the equation for a circle that has a center at negative 4, 3, and a point on the circle is at 5, 3. What I'd like for you to do is to go ahead and hit pause and see if you can sketch this circle on your notebook or a piece of graph paper just to get an idea as to what it looks like. All right, we're running out of time, so we'll finish this one up quickly. We identify the center of the circle right here. The center of the circle is at negative 4, 3, so it's going to be x plus 4 squared plus y minus 3 squared is equal to the radius squared. We don't know the radius, but we know a point on the circle. When we count from the middle of the circle to the point on the circle, it's 9 units, so it's going to be 9 squared, which is 81. And here is the equation. We covered a lot of information in a short amount of time. As always, check with your teacher for more help. Just use this as a starting point as you get ready for your SOL test. Good luck. Do great on the SOL.